All right, so let's look at that same neighborhood, but we're going to do the mail delivery person this time. And I apologize, this is so hard to see where a house is and where a house isn't. So I'm going to try to color code houses first. I'm just going to show you all the red dots in my mind are houses. And so those dots he needs to deliver to. So all of the outside, there's some on the inside, and a couple streets have houses on both sides, and some streets have houses on one side, and some streets have houses on no sides. Okay, so we're going to say that's my set of homes. So this is what we're going to base it off of. So for this mailman, as he walks through the neighborhood, he has to deliver to every single red house. And his goal is to park his Jeep at one spot, deliver to the whole neighborhood, and go right back to that Jeep. And ideally, he does not want to retrace anything. So let's set up the map again, and we're going to try to set it up so we can represent the story of the streets that he does have to walk on, the streets that he has to walk on twice, and the streets that he has to walk on once. So there's the map retraced. Now I'm going to kind of color code here again with my highlighter. Streets with 1, he has to do these streets here, and they are all one-sided streets. It's the whole outside. Right here, cutting through this diagonal cut, and then on the other side of that diagonal cut. And then here in the middle is another place where it's one-sided. Okay, so for a little key here, that's going to be my one-sider, one-sided streets, meaning homes on one side. Okay, and we'll look at one that is two-sided. Oh, that's really dark. Sorry. That's a two-sider home. It's here and here. Sorry that dark blue didn't come in that well. So those are two-sided streets. And for the first time, I'm going to actually highlight another version, and it's actually going to be this little spot here. I don't have any houses on that road. So no, 0 houses. So if you have 0 houses, you don't need to walk on that road at all. So if I try and translate it to over here, I got all the one-sided. I definitely have to walk on the yellow once. I have to walk on the yellow once, and I need to walk on the blue twice, and I don't need to walk on the green. Okay, so I need to walk the yellow once, the blue twice, and the green never. So if you want, what we can do is we can visualize that for the mail carrier by saying, if I need to walk on the blue twice, let me show you the twice. Those 2 are representing twice. This set of 2 represents twice. And it's kind of nice, since I don't have to walk on the green, you don't even need those roads. So in fact, if I don't want to walk on the green, I might as well just erase them because I don't need them for this story. Okay? So here is the route. I took away the green. I need to hit the yellow once because there's houses on one side of the street. And the blue shaded region, there's houses on both sides, so I actually have to walk down that road and back up that road. That's why I kind of represent the story with the 2 blues. Let me put that in because I erased that accidentally. Okay, so from that, we're going to start counting, as we normally do, the even and odds for each corner. We have 2, 3, 1, 2, 3, 4, 3, 3, 4. This corner here has 4 to it. This is the one that has lots to it. You're going to be visiting the middle of the neighborhood quite often. 1, 2, 3, 4, 5. Okay, so those are all of your nodes. Let's turn those into reds and blues. So anything even is red. And that's our goal. We want red. If we have red, it's a circuit and we're good to go. Anything blue means it's going to turn into a path. Like right now it's a path because there's 2 blue dots. But then I add in another blue dot and another blue dot. So there's 4 blue dots, so it's a neither. So 4 blue dots makes it a neither. Okay. So my goal as the mailman is I want to start wherever I want to park. So maybe I'm here, maybe I'm there. I want to start somewhere. Say I start at 2. And my goal is I'm going to have a Jeep. And I want to start and stop at my Jeep so I can drive home after work. Okay, so mailman goes, delivers, walks around the neighborhood, and he gets back. So ideally, he walks on the yellow once, he walks on the blue twice, and he gets right back to his Jeep so he can drive home. But the issue is, you know it won't work because there's 4 blue dots, so it's a neither. So our goal is we're going to try to minimize the number of retraces that I have to do so that I can change all of the blues to reds so I can get back home. So we're looking at the blues and saying, how can we change them? So I can see right here, if I add in, so I'm going to add in a road here. This is a retraced road. Okay, I'll make it brown. If I add that extra walk through, so it's the long walk around, that would change the 3 to a 4. Change this 3 to a 4, which would now upgrade that blue dot, and that blue dot would now become red. So that's good. But now I still need to change the 3 and the 5. So I need to somehow switch those out. So I'm going to have to walk. I'm going to have to retrace some of my steps again. So one route that you could do is you could add in a brown from 5 to 4. That 5 would change into a 6, which means that blue dot would turn red. But what happens here is now this dot here that was a 4 becomes a 5. So I actually changed him into a blue. I didn't really want to do that. I wanted to change everything into red. But if you notice, if you swipe one more time with this brown, this 3 can change to a 4. The 4 was once a 5, but now it's a 6. And that changes him luckily back to a red here and a red here. So what happened is in this neighborhood for the mailman carrier, he has to retrace 3 roads. Those are the brown roads now. He's retracing them 3 times so that he can start and stop at his Jeep. I'm going to show you a route that he could do. Let's do a different style route for him. I'll do it with this snake looking thing. Okay, so we're going to look at it this way. He starts at his Jeep. He can go up, down, up, around, there, around, down, up, over, down, there, up, got it, through, back to his Jeep, and he can drive home. So the parts that he had to retrace was, that was an extra retrace for him. It was here and here. Those 3 kind of flower routes right now, he had already delivered all the mail to those homes, but he had to retrace 3 times to be able to get back to his Jeep and drive home. So no matter how he does it, 3 is the best way for him to do it. So he's going to walk through the neighborhood. He's going to go through the yellow-sided streets once. He's going to go through the blue-sided streets twice. He will not have to do any of the green home or the green strips because there's no houses there. But he's going to have to walk 3 extra roads just to retrace his steps back to his car. Okay, so now what I want is I'm hoping that you guys can take a look at the bottom of this page, and there's a mail carrier problem, and there is also the security guard problem. And for just visualness, let me show you where all the homes are. This one came in a little bit clearer, but there are homes on all of the outsides of the main part of the neighborhood. And then for the interior of the neighborhood, if you can't see it, there's homes around both sides of the spokes in and around the big loop once. So if I would color code for you again, there is all of the outside, okay? Houses on one side, houses on one side. Then there's the interior part that loops. So this blue, 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 okay? And that's houses on both sides, houses on two sides. And in the inside, if you can't see it, there are homes all around the outside of it. It's like a park is in the middle. So this is here, that idea, okay? So that matters when you talk about the mailman, but the security guard, it doesn't matter if it's a yellow or blue. He just really wants to trace through it once and solve. So my question to you on both of these is, how many times will the mailman and then also how many times would the security guard have to retrace steps to get back to his car? So let's say at his Jeep, and where he starts is in that top right corner. So my question is, how many times would he have to retrace roads to get back to his Jeep after delivering to all of the houses, or for the security guard after he's walked all of the roads? So why don't you try this out, hit pause on the video, try out this page, and then afterwards you can hit play and you'll see my answer key to it. But right now, hit pause, try this out for 10, 15 minutes, and then we'll go from there. All right, so I redrew for the mail carrier in the empty space below on your notes. And again, just color coded the yellow and the blue. For the mail carrier, anytime it's a blue, that means there's houses on both sides. So he's going to have to walk down one side. He's going to have to walk back up the other side. That's already, it's not retracing. That's part of his job. He has to walk that one twice. And he has to walk this guy twice and this guy twice. And his goal is he's going to hope to start here and end there. And hopefully he doesn't have to retrace at all. But he might have to. That's what we're going to find out. So from this, we're going to start counting the dots. Even one, let me clarify something. I drew this and it's kind of a little bad how I drew it. When I drew those blues, I was focused on making those blues, but now it feels like in this spot, it feels like there's 3 lines there. I kind of did that wrong. Let me redraw what I meant. So in that blue spot there, I have to walk it twice. So down it once, back up. Down it once, back up. Down it once, back up. I don't want you to miscount that black line that I didn't retrace. Let's try again on my counting. So I have 2 there. 1, 2, 3, 4. 2. 1, 2, 3, 4. 1, 2, 3, 4. Okay, here is 1, 2, 3. 1, 2, no wait, 4. 4. 4. So the mailman loves this one. This neighborhood he loves because he has to hit every house. He will hit every house, and they're all red because they're all even. So there is no retracing beyond what he already has to do in the blue spot. So it's already a circuit. So this is great for mailman. Okay, because I'll show you. If he starts here, he's going to get back there and he's never going to really have to retrace. He goes down, up, back down. Now that's not a retrace and doing more work than he needs to. He had to go down that street twice to get both houses. Over, up, then he can go here, got it, up, over. He goes into the neighborhood, loops around delivering to all of the people on the middle, and then he goes back out and he ends right there. So for him, he never had to do any extra work than what was required. So no extra work. So for this one, he loved it. Let's check about the security guard. Okay, security guard. You don't even care about the homes. You don't care about yellows or blues or greens. All you care about is, sorry about that, people were loud in class. All you care about is tracing those roads. So you don't care about yellows. You don't care about blues. You don't even care about where the houses are. You need to just trace over the roads, and you hope you don't have to repeat anything. Okay, so I'll put it over here so it's a little bit cleaner. Here, dot, dot, loop. Okay, don't worry about yellow, don't worry about blues, don't worry about retracing anything yet. You know this is what you want. You just want to walk through that black once and get back where you started. So you want to start at star and get back. So we're going to see if the security guard can do it. So I'm going to count all of the corners, and then we're going to see if he's going to have to do some retracing. And if you notice here, there's lots of threes coming around. So he is not going to be happy. And what I mean by that is, as I do this trace, no matter how I do it, he's going to get stuck retracing somehow. So he can go all the way through here. Good. But right now, he got stuck at that blue star, and he still needs to cover the bottom part of that circle and the bottom part of the neighborhood. So it's going to be like this detour to get to a spot where he can go get the blue. Now he's mad that he has to retrace this part. Then he can get some more of the blue. Then he's going to have to retrace this little part again and retrace that. All that yellow right there is extra work for him. He's already checked to see if the neighborhood's safe, but he got stuck in no man's land, meaning, oh, I have to retrace it again to go cover everything. So this guy's going to have a little bit more work. So let's figure out how many times he's really going to have to retrace this neighborhood. That means we're going to have to change all of the threes into evens. That's the goal. We want to change all of the blue dots into red dots. So again, red dots are evens. We love the 2 there. And these blue dots means I have more work that I have to do. Okay. So our goal is to try and figure out how can I change blue dots into red dots and make it the quickest way for him to get in and out of this neighborhood and say, we're safe. So one is I'm going to have to retrace that road. So I'm going to show retracing that road by adding an extra line there. That changes this 3. Let me color code it, sorry. That changes this 3 to a 4, this 3 to a 4, which means those dots have become red. That's good. I'm slowly converting this neither into a circuit. So I have the 2 reds, then I change 2 blues to 2 reds. I can do that again. If I go right here, this looks like a quick retrace. Changes him to a 4, changes him to a 4, which means that dot's red, that dot's red now. And if you do the outside part here, that will change him to a 4, him to a 4, which converts these guys to red. So now I've redone the neighborhood by adding in yellow retracers, which have changed all the blue dots into red dots. Those yellow retracers shows which extra times the security guard would have to walk those parts of the road. So I'm going to show it by going, okay, ideally he only wants black, but he's going to have to do those 3 yellows to repeat himself to get back to where he starts. So I'll show you. So I can go secure, 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 secure. He could go up, secure, in, secure. Notice I've done all purple, and all of that purple has been on the black. So far he hasn't done any repeating. He's happy with that. No repeating yet. No repeating yet. Now you see where he gets stuck. So he slides on that yellow. That's an extra retrace that was more work than he wanted, but he had to do it. That was once. covers this area, That's his second retrace. Luckily, that was a quick little snippet. Here, now he's done. His job is done when he gets down to this corner, but his car's way back up at the red star. That's why you had to retrace that yellow back. So we had to do 3 retraces to force a circuit. Okay. So hopefully that gives you a good idea or good practice on how to convert neithers into circuits for mailmen and circuits for security guards. So I want you to take a look at this last page. It's number 50 in a book, and I'm telling you there could be a quiz tomorrow. And this quiz will have this neighborhood, and it will be a quiz about this neighborhood for a mailman and this neighborhood for a security guard. Notice there are lots of homes in this neighborhood. So you know the mailman's going to have to do a lot more work anyways, because he's going to have to retrace a lot of those roads because he has to cover both one side and the other side. For the security guard, he doesn't care what the homes are or how many homes there are. He just needs to go on those roads once. That's all he wants to do. He doesn't really need to go twice, and he doesn't want to go twice. The mailman will have to go twice on some of them. Your goal: force circuits for the mailman, force circuits for the security guard to see how many times are they going to do extra retraces more than they really want to. So this is what I'd recommend as practice right now, especially when the quiz tomorrow will be just like this. Could be this, might change it a little bit, but it's this idea. Good luck. Have a good day.